Everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be in chapter number 4 and lesson number 5. That is on page 181, chapter 4, lesson 5, domain and range of a function. Now, this is going to be a complicated lesson. You're probably going to have questions afterwards, so I need you to pay attention. The words that I say and the words that are on the screen are going to be very important. It's very technical, and so I need you to really pay attention on this one. Don't miss anything. If you do miss anything, make sure you rewind that thing and listen again so that you can figure this all out, okay? All right, the domain and the range. What is the domain and what is the range? Well, that's where we need to start. So look down here at the screen. The domain is the input value. Okay, so we've been talking the last few lessons about the input and the output. Okay, so the input is the x. Okay, that's the input. That's the independent variable. Input independent. Okay, x value. The range is the output values, and that is going to be your y or your dependent variable. Okay, so in other words, it depends on certain things. So typically, I wrote down here, most of the time, wow, that's like most of the time. Okay, so there are times that it's not, but most of the time, the domain, the x, is unlimited, okay? So negative infinity to positive infinity. It's unlimited. In other words, you can put any number you want in for x. There's no limitations. You can put 1, you can put -1, you can put 1 million, you could put -1 million. You could put any fraction in. You could put really any number you want. Unlimited, okay? Many times, okay, now, I wish that I could say every time, okay, that would be easier, but most times with the domain, and here many times with the range, or the range is the y, it is limited. There are limitations on it. Now, when you're dealing with linear functions, there's no limit on the range and no limit on the domain. Okay, both of them are unlimited with linear equations. But we're not going to be dealing with linear equations in the rest of the book. We're going to be talking about quadratics, and we're going to be talking about radical equations, and we're going to be talking about absolute value equations. So really, for the most part, for what we're doing in Algebra 2, for pre-calculus, for any advanced math that you do, most of the time you're going to be dealing with limitations on the range. Okay. So an example of this would be to say, okay, the range can start at 6. And in fact, let me change this to not included to included. So I'll include 6. So the range begins at 6 and it goes to infinity. In other words, the solutions only start at the number 6 and then they go to infinity from there. So anything less than 6 is not a solution. And we've seen those things as we've been going through some of this where we have to limit our solutions because we've done these, okay? Now, we haven't been calling that the range. We've just been calling that our solution. But in reality, when we solve for y, that is the range. So we have been finding the range. We just haven't been calling it the range. All right, now, let's talk about absolute value equations. This is on page number, let's see here, page number 182. Page number 182. In an absolute value equation, they are always going to produce a V-shaped graph. We haven't graphed any of these yet, but when you graph an absolute value equation, they give you a V shape. So I have a basic graph right here. We could do our lines like this, so we could put it on graph paper if we wanted to, and then a V shape forms, okay, from the absolute value. Now, let me erase some of these lines so you can see it a little bit more clearly. Here's the trick here. Don't forget that this is the x-axis and this is the y-axis. Okay, now notice that any line always goes on a graph, the lines always go into infinity. So In other words, on an absolute value, how far does the x go? How far does it go on the x? In other words, it's going to keep going on the x, right? It never stops. And look, to the negative side of the x, there's also no limitation. Okay, so in this one, the domain, the x, okay, the x is the domain. The domain is not limited, okay? So if we come over here, I thought I had that written, but I don't. The x equals, let me change the color here. The x equals, the domain is negative infinity to infinity. It's unlimited. There's no limitations because the x keeps going. That line is going to keep going forever. And so, in other words, this x can go however big or however small. Now, notice something right here. Notice what the y would equal. Okay, this is kind of the trick right here. This is the range. X is the domain, y is the range. Look, I've got a limitation right here, don't I? What is this point called? Really important. The vertex. What limits the y is the vertex. Okay? So the y is limited by the vertex. In this case, the vertex is on the y-axis. So what's the limitation? The limitation is 0 in this case. Now we can move it up and down, but the limitation is 0. How far does it go up? How far does this thing go up? Well, infinitely, because look, it can keep going, but it only can go down to here and it stops at the vertex. Okay, so it could go to infinity. So that would be our 0 is included, okay, and our infinity is not included because you can't include infinity. Okay, so in this one, our domain, infinite. Our range starts at the vertex, 0, and goes up infinitely. So 0 to infinity. Now, what does that look like on here? Let me show you this graph right here. All right. So if we're going to graph this, we are actually going to graph. Let me make a number here that's a little bit better for you. Let me put just 5 right here. Okay. It'll be easier to count 5. That's why I did that. So if we go up 5, this is where our vertex is going to be in this case. And in other words, it's going to give us a V right here at 5. So in this case, because 5 is the K, and we've done that, okay, it's the constant. Okay, so the vertex equals K, or the constant. All right. So in this case, 5 is our vertex because 5 is our constant. So the y value, or the range, write it over here, the range is going to be from 5 to infinity. 5 would be included, don't include infinity. Okay, so you would start at the constant because that's where the vertex is, and we're gonna go over this more. I know this is kind of like sometimes I think this lesson kind of gets the cart in front of the horse in the book, but once we get to the lesson, you're gonna be like, oh, okay, that makes sense now. But this is the K, this is the constant, and the range is limited. Okay, the important thing is that you know that in an absolute value, the range is limited by the constant. The constant limits the range. The domain, not limited. Infinity, because of this, it goes forever in both directions. Okay, so I wrote down here, and if you want to write that down, this is important because I wrote this right here, and you're like, what is that? See that right there where I wrote that's, you say that function of x, function of x. So in functions, we replace the y with function of x. Okay. What is a function? A function is just has an x and a y. So instead of writing a y there, we're going to write function of x. You're going to start seeing that. You can actually substitute these. These are interchangeable. You can put y in for it, or you can put function of x in for it. Doesn't matter which way you write it. You're just going to see the book writing it this way, function of x instead of y. Okay, so in these absolute values, right here I wrote this, your range will always be from the constant, in this case right here, from the 5 to infinity. And the domain will always be infinity, negative infinity to positive infinity, or all real numbers. Okay. The next one that we're going to look at is the quadratic function. And this is in your book on page 183. Page 183. The quadratic function. Now, we're going to learn a little bit later how to find the vertex, but right now they're going to give you the vertex. Okay. Now, if you remember a very simple thing that I told you earlier, and I said that the x was the domain and the y was the range. Okay. So when you look at this, you're like, wait a second, the x, I don't understand what you're saying. Well, when you graph this, what ends up happening, and here's this right here. Okay, that's our quadratic, and that's a function. Okay. When we graph this, you have to solve for this, and then you find your points and all this other stuff. So when we get to that, when we start graphing these functions, you're going to see that the range is being limited. It's going to be like a U shape. This is called a parabola. Okay. Now I want to show you what look, the domain, the x, because look what's happening. It just keeps going. Okay. The x just keeps going. So this way and this way is unlimited. The x again is unlimited here. Okay. Like I said, the domain almost always is unlimited. What is limited again in this one, look, the range is limited by the y value or by the vertex. Okay, so what is our vertex? It's at 8. So if I count up 8, 1, 2, 3, 4, 5, 6, 7, 8. This 8 right here is what limits our y. Or in other words, the y stops at the number 8. So in this case, our range would be from 8 included, okay, until infinity. Why? Because it keeps going up. Now, another thing that can happen with these is sometimes these things can go downward. And so let's say that I start one right here. And I'll go to this point, and it goes down. Well, the x is still going infinitely out, okay? But now the y is being limited, but it's down. And remember, this is negative, that when you go down on the y, this is negative. So in this case, let's see, it's 1, 2, 3, 4, 5. So in this case, it would be 5 included to negative infinity. And you actually would write that the other way. You'd flip that around. Negative infinity comes first. Negative infinity, comma 5. 5 would be included. You can't include infinity, so you wouldn't write it this way. You'd write it this way. Some negative infinity, so going up until it hits 5. That's a limit. It can't go any higher. Why not? Because the equation won't let it. Okay, so the domain, almost always unlimited. The range is limited by the vertex. It's limited by the y value or by the vertex. Okay, the last one is on page number 183. This is the radical functions. The radical functions. What about when we get something that looks like this right here? Here's an example of a radical function. The function of x equals the square root of x plus 4 plus 5. Okay. This is a radical function. Why? Because there's a radical. That's what makes it a radical function. All right, so Here's the question. What is the range and what is the domain of a radical function? In this one, and only this one, notice what it says. Both the domain and the range are limited. Both of them this time. Normally, the domain is not limited, but in this one, the domain is limited. And let me tell you why. Because this x value right here is under the radical sign, okay? What limits that? Well, a positive, no, you could never have a negative x in there, right? No, you can't have a negative x. So you'd have to have a positive x. So let me show you how to find this. Here's the trick. If you go to if you're looking for the domain, take this right here, set the radicand greater than or equal to 0 and solve. That's the trick for finding the domain of a radical function. So let's take the radicand, this right here, and we're going to set it greater than or equal to 0. Why? Because it has to be positive. It can be 0. You could have the square root of 0. That's fine. That just equals 0. Okay? But what you can't have is the square root of a negative number. That equals imaginary. So we can't have an imaginary number right there. So let's go back and let's say, now I'm just going to take the radicand. Okay? I don't need the square root sign or anything like that. Let's just take the radicand. So x plus 4 has to be greater than or equal to 0. So let's find where we're going to start. Where's our domain going to start? Well, I just solve for x. Minus 4, and I get cancel here, and I get x is greater than or equal to negative 4. So where is this one going to start? And you can always check this. So look, if I go negative 4 plus 4, that's 0. I always want to get 0 in here because that's where we're going to start. We can only start at 0. That's our starting point for our range. Okay? And so in this one, our range will be negative 4 to positive infinity. Negative 4 to infinity. Can't include infinity. Negative 4 is included. So we'd put a bracket on that. Okay? So this is our domain. Okay? Well, how do we find the range? Well, let's go back up and look at what it says here. All right, to find the range starts at the constant and goes to positive infinity. That's positive infinity. That almost looks like TOO, but it's not. It's positive infinity. Okay. Now, what does that mean? Well, let's just take it for face value. What is the constant? Remember, the constant is the k. So what is the k here? The k is a positive 5. And so it's very easy to find the range of these. We just take the constant to positive infinity. So the range is 5 to infinity. 5 would be included, infinity would not be included. So the domain of this one is negative 4 to infinity. How did we figure that one out? Well, we followed this rule. Domain, set the radicand equal to, or greater than or equal to 0 and solve. And then the range is 5 to infinity. How did we figure that out? The range starts at the constant, which is the k, and goes to positive infinity. All right, wow. That's a lot of stuff. That was a big video, long video, and an intense video. Lots of vocabulary, lots of new things. You need to go back in there. You need to look through your book. Your book has a really, really nice chart, and it is on page 186, I think. Let me get to it. 186, yes. So if you'll go to page 186 in your book, you're going to see Table B. Table B. That table is your friend, okay? So it gives you the function type, it gives you the general form, what it typically looks like, and then it gives you the domain, how to find it, and it gives you the range, how to find it, okay? Really, really valuable table right there, Table B. It's like a little shortcut. This is a cheat. When you're doing your homework, look at Table B, because that's really going to help you out a lot, okay? All right, hope you got everything there. If you didn't, please go back, rewind that, watch this video a second time because there's so much in there. It's action-packed video, okay? All right, we'll see you later. Have a good one. Bye-bye.